Alright, so here we are with simplifying radicals, and we're actually doing the notes as part of the worksheet. So, that's what we have here. First thing we're going to want to do is define what a radical is. A radical can actually be one of several things. Most likely, you're going to get a square root. So you've got that little symbol there. But it can actually be any root. So there's also something called a cube root. We also have a fourth root, a fifth root, etc. So all of those are radicals, and that's why we don't just call them, square roots, because radicals does include cube roots and any other degree of root. So what's a root actually asking you to do? It's saying what times itself will make the number inside. Okay, so what times itself makes that number inside, which is 9. If there was a little 3 here, we would say what times itself 3 times will make that number, and that's where we get things called irrational numbers, and that just means that they don't actually have a ratio that they could make. So, for instance, pi is irrational, and any square root of any whole number that doesn't then become a whole number is going to be irrational as well. Basically, the decimal does not repeat and it doesn't end. Alright, so in order to get there, notice that we're saying times itself, and so we're going to end up talking about perfect squares, which are numbers times themselves. So for instance, 1 comes from 1 squared, 4 is 2 squared, 9 is 3 squared, and so we need to be very familiar with these numbers in order to get through what we need to do here. So 25 is 5 squared, then we also have 6 squared, which is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. We could potentially do more values after this, but at this point we'll just start with up to 12. So, the first thing that we are going to do here is talk about why we would simplify. Okay, and so what happens is, most likely at this point you're saying, okay, square root of 25 isn't actually the answer, you're just going to plug it into your calculator and say it's about 11.818. Okay, cool, except that's about the answer. Okay, and so we don't actually want that anymore, we want the actual answer. And so instead, we're going to say that it's the square root of 125. However, we're going to try to pull out as many whole real numbers from that as possible. And so if you look on ahead, for instance, you see here there's this whole number out front and then this leftover part. That's what we're going to try to make out of this first line here. So how do we get there? The idea comes from the fact that you could say you owe someone $10, but you could also say you owe them 2 times $5 or 2 $5 bills. Okay? And so it doesn't actually change the amount, right? You still are going to give them 10, but it does allow you to kind of break it up into pieces. You don't have a $10 bill, you have 10 ones, or whatever it happens to be. So in this case, we're going to try to break up 125. Well, how do we break up 125? We try to find a number within this list that divides evenly into it. You always want to start at the largest number so that you don't have to continue to reduce. It's kind of like fractions, how you have to divide the top and the bottom by the largest one so that you don't have to keep doing it. However, if you do divide it by a smaller one, you just note that you have to do it again. So, the only way to start without necessarily knowing a lot of divisors is just take 125 and start dividing by 121, 100, 81 until you finally get to a number that goes into there evenly. So, it turns out that we are going to take 125 and rewrite it as 25 and 5. 25 times 5 is 125. It's perfectly acceptable. Alright, the next thing that we are going to do is realize that the square roots can be split up as long as it's multiplication. So if there was addition in here, which we will see later, you cannot say it's the square root of 25 plus the square root of 5. However, because it is multiplication, we can say that. So that means that I'm going to split this up into 2 different radicals, and so I'm going to get the square root of 25 times the square root of 5. Notice that I am putting equal signs each time because these are technically all the same value. If you plug them in, you would still get that 11.18 decimal. Alright, so now we're actually given two pieces that we can simplify. For instance, the square root of 25 is much easier as 5, right? It's a lot more recognizable. But then the square root of 5 is that irrational number that can't be simplified anymore. You definitely know you've simplified enough because you have a prime number inside, okay? Or at least a number that is not divisible by any of these values up here. So, the answer is going to be 5 square roots of 5. And if you think back to maybe some answers that you've seen on our answer sheet, sometimes they will say things like this, 5 square roots of 5, and you're like, but I got 11.18. Cool, because that is what 11.18 is, but it's in its reduced exact form. We never want to cut off a decimal if we don't have to. Alright, so you're going to try that for number 2 and 3 as well in your assignment. If we move on to the next one, you'll notice that we end up already having a whole value out front, but we're going to try to take this square root of 80 and do exactly what we did with 125 and simplify it a little bit. So we go through all of our numbers and find out if anything can divide into 80. So 49, no. 36, no. 25, no. I believe 16 can't go in there, but you can always just check with the calculator. Oh my gosh, it can. So in that case, I'm going to keep the 5 out front, but then I'm going to rewrite the square root of 80 as 16 times 5. And I tend to write the thing that's a perfect square first, just because then I can think of it going out front to multiply. So if we simplify that a little bit more, we're going to actually take the square root of 5 and multiply by the separate square root of 16, and then the separate square root of 5. Of course, the square root of 16 is actually 4, and so we end up with 5. Whoops. I gotta scroll that up. Okay. 5 times 4. And then that square root of 5 still. Of course, we try not to just say 5 times 4. We would simplify that, and so we are going to end up with 20 out front, and then the square root of 5. So the only thing that's different about this one and the previous problem is that there just happened to be a number out front that you then carried down through the problem and multiplied it. Okay, so again, that will be happening in these next two. You can try those. And then the last piece here has division. Basically what division does is separate this into two problems. So we've got the numerator problem and the denominator problem. So we'll solve them as we did the previous, like number 1. And then once we put them on top of each other, we might be able to, for instance, if these were on top of each other, we'd be able to reduce the 5 and the 20 to be a fourth, and then actually cancel the square root of 5s. So we're going to go ahead and see what we can do to rewrite this. So basically I'm going to do a side problem of the square root of 200, simplify that, and then another side problem of simplifying the square root of 243. So I look through my list here and I'm trying to find out what is a perfect square value that can divide into 200 equally, and definitely 100 can do that. So if I rewrite this as the square root of 100 times 2, I can actually rewrite that as the square root of 100 times the square root of 2, and so we get 10 square roots of 2. So my numerator is 10 square roots of 2. The denominator, however, taking a look at 243, trying to find out what divides into 243 evenly. And so if you don't know, you can just do 243 divided by 121. Nope. 243 divided by 100. Definitely not. 243 divided by 81. Oh, is 3. So that means that I rewrite this as the square root of 81 times 3, or potentially the square root of 81 times the square root of 3. And so we end up with 9 square roots of 3. So moving back up to the top, we've got a 9, a square root of 3, and then we look for separate pieces. So we take this separate of 10/9 and see if we can reduce that, which we can't. And then separately we look at the square roots. Are they the same? Is there something we can reduce in them? Which again we cannot. And so in that case, this is just our very large reduced answer. The idea, again, is that you now have a better estimate of what the decimal equivalent of square root of 200 is, because you know it's going to be 10 times the square root of 2, which is going to be something in the ones, like 1.4 or something like that. So in that case, you can kind of more easily estimate that this value is a little less than 20, or whatever it happens to be. So again, it's easier to estimate based on this simplification. Now, of course, since we did this in what we're going to call the forwards direction, since we just did it that way, we're also going to do it in the backwards direction. So notice this is asking you to write this as a single radical. So you could have 2, 3, or even 4, or however many radicals you want multiplied. But remember that the idea is that when we had the radicals multiplied by each other, it's because they came from one radical. So applying that over here, that actually means that I can rewrite number 10 as inside 7 times 3. Right? If they were separate, you can put them together, and now we have 7 times 3 in one single root. Again, when you're simplifying, this will be a lot easier to help you, because maybe both of the numerator and denominator have some sort of root in them that could cancel, and so you would want to put it back into a larger root. So we can make larger roots, and we can also make smaller simplified roots. So this is going to be our answer to writing the single radical. Alright, so that's what you're going to do for your notes here today, kind of taking a look at each of those. Hopefully you took the time to pause the video and solve them. Of course, we'll post the rest of this worksheet tomorrow with its answers, but you can continue to work on it today if you would like. Sweet.